If you drink coffee at lunch, could it still change your sleep at midnight? And is one ordinary dose comparable to a large caffeine hit? Those questions are often compressed into a single rule: stop caffeine a certain number of hours before bed. But the research points to a more useful question. Not just when did you drink it, but how much did you take, and how closely does the study population resemble you? Let's look at what the experiments actually found. The clearest recent test was a placebo-controlled, double-blind, randomized crossover trial. 23 healthy men, averaging about 25 years old, completed 7 conditions. On different test days, they received placebo, 100 milligrams of caffeine, or 400 milligrams, with caffeine scheduled 12, 8, or 4 hours before their usual bedtime. Because each participant completed every condition, the researchers could compare a person's sleep after caffeine with that same person's sleep after placebo. Sleep was measured at home with partial polysomnography, alongside sleep diaries. The central result was a dose split. In this trial, 100 milligrams did not produce a statistically significant change in either objective or subjective sleep compared with placebo at the tested times. 400 milligrams did. That does not prove 100 milligrams has no effect for everyone. The sample was small, and the closest test was 4 hours before bed. But it does mean we should not take a result from 400 milligrams and casually describe it as the effect of any cup of coffee. Now the striking number. When the participants took 400 milligrams 4 hours before bedtime, their objectively measured total sleep time was an estimated 50.6 minutes shorter than after placebo. The effect estimate was statistically significant. The same study found smaller, non-significant estimates for total sleep time when that high dose was taken 8 or 12 hours before bed. So the data do not justify saying that 400 milligrams always removes a fixed amount of sleep. Timing changed the pattern, and statistical certainty changed with it. Total time asleep was not the only measure. 400 milligrams reduced estimated sleep efficiency by 9.5 percentage points when taken 4 hours before bed, and by 6.9 points when taken 8 hours before bed. Sleep efficiency is simply the share of time in bed that is actually spent asleep. This matters because someone can spend the same number of hours in bed while having more wakefulness and fragmentation. Still, these numbers come from one small, controlled trial, not from every coffee drinker in daily life. A broader review helps explain why researchers look beyond simple sleep duration. It synthesized 32 human studies that measured sleep-related brain activity with EEG. Across very different protocols, its most consistent finding was lower low-frequency activity during non-REM sleep, especially slow-wave activity and the lowest delta frequencies. In plain language, caffeine often shifted the sleeping brain away from the deepest low-frequency pattern. But an EEG pattern is not automatically a diagnosis, and it does not by itself prove a specific health consequence the next day. What about ordinary life rather than a controlled capsule experiment? A separate cross-sectional study examined 428 employed adults. Higher total caffeine intake was correlated with higher scores on the Pittsburgh Sleep Quality Index, which represents poorer reported sleep. But the researchers explicitly warned that their design cannot establish causation. They also did not record when during the day participants consumed caffeine. Poor sleepers might use more caffeine, caffeine might worsen sleep, or other factors might affect both. An association can raise a useful question without answering it. Why is a universal cutoff so hard to defend? The EEG review identified dose, timing, habitual use, withdrawal state, age, circadian context, and genetic variation as factors that can change the magnitude of caffeine's effects. Products also vary in caffeine content, and people do not all metabolize caffeine at the same rate. The safe conclusion is narrower than a viral headline. A high single dose can affect sleep even when it is not taken immediately before bed, while a lower tested dose produced a different result in this particular trial. There are also important boundaries around the experiment. It included 23 healthy young men with moderate habitual caffeine intake, women, older adults, people with sleep disorders, and people taking medications that affect sleep were not represented. Caffeine came in capsules as a single dose, not as coffee slowly consumed with food. Each condition contributed 1 night of sleep measurement. Those design choices make the comparison controlled, but they limit how confidently we can translate the exact numbers to every viewer's routine. So what is the practical interpretation without pretending the science is more precise than it is? Start by separating dose from clock time. A rule based only on the hour can hide a 4-fold difference between 100 and 400 milligrams. If sleep is a priority, check the caffeine amount on the actual product, notice when you consume it, and observe your own sleep consistently. Do not treat this video as a personalized medical cutoff. The evidence supports caution with high doses, especially closer to bedtime, not one guaranteed deadline for everyone. The memorable takeaway is simple. The caffeine cutoff is not one number. Dose, timing, and the individual all matter, and the strongest result here came from a high 400 milligram dose. If you want more careful breakdowns where the claim stays attached to the paper, subscribe to Science-Backed Life. And tell us, have you ever changed the timing or amount of caffeine and noticed a difference in your sleep?